Hello and thanks for tuning in. I'm Daniel Kovac with the second installment of the R tutorial. Today we're going to talk about control structures, defining functions, and other useful and handy R utilities. So let's get started. As usual, I'm on the Windows operating system running R out of Cygwin. If you need some help setting this up, please check out my other tutorial. We're going to start with a very simple for loop that counts from 1 to 10. I use the for keyword followed by an open parentheses, and I use an indexing variable which I'll call I, close the parentheses, and next I'm going to use curly braces and insert the body of my functionality. Notice above I use the C or combine function to specify the range over which I'm going to iterate, but as you see here I can just use the colon operator by itself without the C function and it should work just fine. Obviously, I want to be able to do more complicated things than just print out an indexing variable, so here I'm going to call a function that we defined in the previous tutorial, and I'm just going to print out its value. Notice here I'm not taking a new line for the body of the code, I'm just inlining it, which is fine as long as I obey the R syntax of the curly braces. Lists are important data structures in R or any programming language for that matter. So let's call one here. I'm going to call it res for result and just use the list keyword. And next I'm going to use my for loop to append values to this list. I can do that by calling the combine function and reassigning my list to its result. Now, R is really good with vector-wise comprehension, so if I just insert my indexing vector directly into a function, it should be able to make sense of it. Notice here the result is very similar to that of above, except I have a vector instead of a list. While loops are another very common control structure in programming. Let's see how that's done in R. I'm going to define two variables, one for my condition and one for my index. Similar to the for loop, I'm going to call my keyword first and then insert my condition into parentheses. Again, I insert the body within curly braces. So here I'm just printing out the value of the indexing variable like I did in the for loop, but this time I have to remember to update my indexing variable. As anticipated, my output is 1 through 10. R makes it very easy for us to choose some random values using the sample function. I simply call the function with a vector of values as the first argument. Next, I specify how many I want. If I'm okay with duplicates, I simply set replace equal to true. This is especially important if I'm requesting more values than my vector has elements. In such a situation, R will throw an error. Let's see how conditionals work in R using the if, else if, and else keywords using the sample function as an example. I'm going to compare a randomly chosen number with a predefined guess and print a statement if these two match. As usual, I call the keyword first, place the conditional in parentheses, and the body in curly braces. Here nothing's printed, so I know that those two values didn't match. So that we can reproduce this little game, let's go ahead and define a function for it. I'm going to call it game, and I use the function keyword to set up that function without any arguments because I don't need any. Everything's within the function body. Here I'm just reiterating the code from the previous example. Notice how the first argument in the sample function is a vector that spans 1 to 3. This means I have a 1 in 3 chance of getting it right. This final curly brace concludes the function definition. Now I can call it successively. Sometimes we choose correctly, sometimes we don't. Now let's throw a variation to this. I want to use my if statement as before to compare a randomly chosen value with a predefined value and see if they're equal. But this time I want to use the else statement to let me know when the values aren't equal. So in other words, I have a condition for when they are equal and also a condition for when they're not. Again, I'm going to use the if and else keywords. The syntax for these is very similar to C or C++. Again, my condition goes in parentheses, and the body of my code goes in curly braces. After concluding the body of code of the if statement with a curly brace, I'm simply going to call the else keyword and add another body of code. Notice that the else keyword does not need a conditional because this is what happens when the condition above is not true. Just like before, I have the ability to call this function successively, and this time we see every single time I call the function, I get a printout. R actually gives me the ability to sum up the functionality of the previous example in one line, using the if-else function. Here I'm going to define a new function that is going to repeat the functionality from before using the if-else function. Again, the rules of the game are the same. I choose randomly from 1 to 3 and compare that with an initial guess. This time, the condition is the first argument of my function. Next, I specify what to return if that condition is met. Finally, I specify what to return if the condition is not met. As you can see with the output, I have the exact same functionality but with a lot less code. In this final example, we're going to add one more piece to the if-else conditional, and that's else if. Else if is used to append additional criteria. Again, in this example, I'm choosing from 1 to 3 randomly, but this time I'm comparing it with 2 initial guesses. Again, I'm comparing it with 1 as my first initial guess, but also I'm going to specify a second guess, and that value I'm just going to set to 2. Notice that thus far the code is the same. Here's where it changes. I'm going to add the else if keyword followed by a parentheses containing my extra criteria. In this case, I'm checking to see whether my randomly selected value is equal to my second choice. Finally, I add an else to cover all other possibilities. But note, since I'm only choosing from 1 to 3, I could have added an extra else if and compared that choice to the third value. As before, let's conclude our function definition and call it successively to see if all of those code branches got hit. R is primarily understood as a statistical programming language, so manipulating data frames is really one of its strengths. Let's visit an example of some stock data I downloaded from Yahoo Finance. If you want, you can check out a previous tutorial that I made on how to download this data directly from R, but this time I'm just going to read it in from a CSV file. Before we get started, notice that the column names are specified as the first row of the data frame. The first step is going to be to get R to read that data frame. Notice how the file is located on my desktop here. I've set the path of working directory to my desktop. That way I don't need an unwieldy file name to get to my data. Since the data is in CSV format, I simply call the read CSV function. Next, I supply the file name. I'm going to store the resulting data frame into a variable I've creatively named data. There weren't any errors here, so I can safely assume the operation was a success. Let's see how many rows of data we have with the nRow function. Unless otherwise specified, R understands that the column names will be supplied in the first row of data. We can get a brief statistical overview of each column using the summary function. Here I'm going to use the column slicing abilities of R to only select the numeric data. After all, R doesn't understand that the first column is a date just yet, it still thinks it's just a string. As you can see, summary outputs some useful information such as the mean, median, max, min, and more. Let's select the highest high using the max function. You can reference that column using the $ operator followed by the column name. Next, I'd like to find the index at which that occurred. That way I can get other useful information like the date. Using the which function, I can obtain the index at which the high column was equal to its max. Since there's only one maximum value, the which function will only return one value to me, and that will be the index at which that value occurred. If multiple values satisfy the condition, then the which function will return a vector of indices. In this example, element number 603 satisfied the condition, so let's store that value into a variable. Using this index variable, I can call up the entire row of the data that satisfied the condition. Notice that comma in the syntax is mandatory. That's because R wants you to specify the rows and the columns. If I leave it out, it will error. Equally important as the ability to read in data from file is the ability to write it out to file. Luckily, R has a bunch of built-in functions to help us with this. I'd like to output in terms of a CSV file, so I'm going to use the write.csv function followed by the data that I want to output, followed by the file name, and this time I'm going to use the separator argument here. Watch what happens. Notice I get a little warning message because I don't need to use the separator because that's implicit in the fact that I'm using a CSV file. When I do it this time, I don't get a warning message. Opening up the file, it looks like this. Looks kind of messy. The reason for this is the end-of-line character. It's a carriage return in Windows and a new line character in Unix. So this time I'm going to use the EOL argument and specify the carriage return manually. This time when I open up the file, all the columns are formatted neatly. The column names have quotes in them, which I find annoying, so I'm going to change that by using the quote option and set it equal to false. Let's open up the file again and see what the result looks like. Good, no more quotes, but there's still one thing I want to change. Notice that the first column is unnamed. This is because that's how R designates row names, and it does this by default. So I'm going to go back to my function call and add yet another parameter, and that's row names. I'm going to set this one equal to false, just like I did with the quotes. Let's open up that file one last time and see how it looks. No row names and no quotes. Those were some of the options I like to use when outputting to file, but you can check out some other options by typing in $write CSV. That brings up a little help menu that shows you that there's a lot more options that you can use. There's also a little write-up about the function, and I can use VI-style directional keys to navigate the menu. When I'm done, I simply press Q and that takes me back to the R terminal. Next, let's discuss some handy miscellaneous functions. These are functions that are very useful, but I didn't really find a specific place to put them in the tutorial, so I'm grouping them all together. Like Python, R is non-typed, so I can use the class function to grab the data type of a given variable. If I'm working with a bunch of variables, I can use the ls function to list everything in my terminal session. The rm function lets me remove variables to clean up my memory space. Note the similarity between the ls and rm functions of Unix, which we all know and love. Now let's discuss assigning data to variables. In particular, we'll look at vectors. We already discussed the combine function C and used the colon operator to generate a range of values. Here we're generating 1 through 10. If I want a vector of all one value, I can use the rep function or repeat and specify that value and how many I want. Next, let's talk about slicing data. We could do this with the which function as we did before, or we could use a subset function. It's a bit more verbose, but it gets the job done. All I do is I specify my data frame and the condition I want that slice to satisfy. In this case, I'm only grabbing one row at a particular date. Of course, I'm not only limited to one value, so let's use a condition that selects for more. In particular, let's consider the price of the stock. In this case, I want to select all the data such that the opening price is greater than $33. Again, I can get a snapshot of the statistical properties of my data frame using the summary function. The head function returns the first 6 rows of my data frame. I can change that value if I want to with the parameters of the function. Similarly, the tail function returns the last 6 rows of my data frame. Again, I can change that if I want to using the parameters of the function. Finally, let's have a look at some of the basic statistical functions in R. This is a big strength of R because functions like mean, standard deviation, and correlation are included in the base package, whereas in a language like Python, you would either have to define them yourself or import a library that has them. Let's pull in some data that R has included by default. In particular, let's use the EU stocks dataset, which contains data from Euro stocks. In particular, it contains the closing prices of the DAX, SMI, CAC, and FTSE. Using the class function, we can see that this is a hybrid data type, which I'd like to coerce into a data frame. So I'm going to use the asDataFrame function to force this data into a data frame object. Again, I can use the class function just to verify. Now let's say, for example, I wanted to find the mean of the DAX. So I'd call the mean function and use the $ operator followed by the DAX data frame name. And as you see, I get that result. If I want to find the standard deviation, I use the SD function in the same way. If I want to find the variance, I call the var function. The correlation function in R is simply COR, followed by 2 variables, because the correlation function inherently takes 2 arguments. So let's take the correlation between the DAX and the SMI. As expected, they're highly correlated. Lastly, but certainly not leastly, we can look at the median function, which is creatively named median. Obviously, these examples were somewhat idealized, but the idea was to give you enough of a background that you can have a springboard into diving into your own problems and getting your hands dirty with those. If you like this tutorial, please check out some of my others on quant finance and R. Thanks again for tuning in. Please don't forget to like and subscribe.